Hello everyone. In today's video, I am going to go over some of the notes, mainly an example of each type of problem, and then I'm only going to do the circled ones and the rest of them are going to be up to you to fill out. I do have the completed notes posted as well, but I'm only going to take a few of the problems themselves and fully explain with a video. So, starting with number 1, what we're doing in this section of problems is we are evaluating the expressions, and they actually give us the value of each variable. So we don't need to just simplify here. We can actually get an answer. So it tells us that A is -4, B is 5, X is -1, and Y is 1/2. So starting with 1, we have 7 times, in parentheses, A plus 4 plus 3B minus 8. So first thing you want to do is plug in your numbers for the letters. So we know A is -4 plus 4 plus 3 times B is 5 minus 8. From here, how you go about the simplifying goes according to order of operations. Hopefully you remember PEMDAS. Please excuse my dear Aunt Sally was the acronym they typically used. Now what this actually means in math terms, parentheses, exponents, multiply, divide, add, subtract. That's the literally order of operations. That's the order in which you do things. Something I want to note, I want you to look at MD and AS as being kind of together. These can be done in either order. So for these two, go left to right. If division comes before multiplication and that, then go ahead and do the division. Whereas if you go left to right and you see multiply first, then you can do multiply. There's no harm in doing multiplication then division, but this is just an accepted thing in math in general. But the others, the order from here, make sure you do things in order. So start with parentheses, then your exponents, so on and so forth. So for this problem, we have one set of parentheses to focus on. That's this here. This parentheses over here, this is around a single number. So this isn't the same thing as these parentheses. This is actually just telling us it's 3 times 5. So this would be multiplication. So just be careful of that. So we want to simplify what's inside the parentheses first. -4 plus 4 gives us 0. Plus, bring down everything else. 3 times 5 minus 8. From here we've got multiplication, multiplication, and subtraction. So I'm going to multiply in both places. 7 times 0 gives us 0. 3 times 5 gives us 15. And minus 8. From here, we're going to add and subtract just as it comes. 0 plus 15 is 15. Minus 8 is 7. Number 2. X over 4 plus y squared. Again, substitute your numbers. X is -1 over 4 plus y is 1/2 squared. All right, so the first thing we want to focus on is this here. Since we have an exponent, we're going to do that first. Reminder, this is the same thing as 1/2 times 1/2. The exponent tells you how many times you multiply the number by itself. So if I had a 3 here, I would have another times 1/2. When you multiply fractions, you just multiply straight across. 1 times 1 is 1, 2 times 2 is 4. So this is -1/4 plus this is just 1/4. -1/4 plus 1/4 is 0. Number 4, square root of a squared plus 9 plus the absolute value of a. Plugging in, a is -4. So we have -4 squared plus 9 plus the absolute value of -4. When you draw absolute value symbols, I recommend you take a second to darken the lines so they don't look like a 1. All right. From here, when I'm doing these problems, especially when you have a square root, I look at what's under the square root first, and then I'll go out to here. So under the square root, I have -4 squared plus 9. So we're going to have to square this first. Negative 4 squared is a positive 16. Remember, this is like negative 4 times negative 4. 4 times 4 is 16. Two negatives when multiplied are a positive. Plus 9. Plus absolute value, reminder, an absolute value is a number's distance from 0. So how far is negative 4 from 0? It's 4 spots away from 0. The trick to the absolute value symbol, when you see it, you take the number that's in it out of it, and it's always going to be positive. So negative 4, we have a 4. And then if this were a positive 4, of course, it would still just be 4. Okay, from here, adding under the square root first. We can't bring that 4 in yet because it's not inside under the square root. 16 plus 9 gives us 25. Plus 4. Square root of 25 is just 5. Plus 4 gives us 9. So that's all I'm going to do from the top section, 3 and 5. I want you to try those on your own, or at the very least, you can get them from the completed set of notes. Coming down to the bottom here, simplify the following expressions. Make sure your answers are in standard form if possible. I am, to make this a little bit more clear, going to give you the standard form definition, so that it'll make more sense when I explain it. Standard form is when you have exponents they are in order from biggest to smallest. So for example, we could have 4x cubed plus 2x squared minus x minus 15. Notice how the x's are in order with the largest exponent first. We have the 2, then we have 1, and then this has no exponent. So this has no variable, so it's going to be at the very end. So using that logic, we're going to apply that to number 6. So first thing we want to do on these problems is look and see if we have any like terms we can combine. So you're going to look for something that has the same variable attached to it. So here we have 7x squared, and we have a negative 4x. The problem is they have the same letter, same variable, but their exponents are different. So I should have specified same variable and exponent. We cannot combine these because they don't have x squared on both of them. Here we have y's on both of these, and they're both squared, so I can combine this. 3y squared plus 2y squared is 5y squared. For my final answer, I need to make sure that this is in the correct order it needs to be according to standard form. So you want to make sure that the largest exponent goes first. Well, notice we have 2 with the same exponent, 7x squared and 5y squared. From here, there's another order you want to follow, and that's alphabetical order. So if you have 2 with the same exponent, but they're different letters, put the letter that comes first in the alphabet first. So that would be 7x squared. And then I'll have 5y squared. And then bring down the minus 4x. You may think that the minus 4x needs to come in the middle, since alphabetically it comes before y, but the y squared is going to come first because it has a higher exponent. So this is the correct way to write this expression. Flipping over to the back. I picked out quite a few problems on here because each equation just kind of adds at an extra level of difficulty. So number 10, we are just solving equations here. This is our typical two-step equation. So the goal is to solve for x, get x by itself. Side note, I drew this line down here. I do this for a few reasons. One, I draw it down, the equal sign, so that you can visually see left side and right side. And 2, it helps students remember that the equal sign stays here at all times. I'll sometimes have students move the equation to other part, or the equal sign to other parts of the equation, and obviously that's going to mess up your answer. So it's just kind of a guide, if you will. So we're going to first move the constant. So that's going to be our negative 7. We need to move it away from 9x. Since it's a negative 7, I'm going to do the opposite, which is add 7. And we do that to both sides. That cancels, leaving just 9x. Now this one cancels as well, since I have another negative 7 plus 7, but I can't just leave this blank. So think about it. What is negative 7 plus 7? It's 0. So I'm going to put that 0 there. Second step, I have 9x over here. This is like 9 times x. If I want to solve for x, I need to do the opposite, which is divide by 9. This cancels. 0 divided by 9 is 0. I have my answer. Number 11 adds an extra step because we have two variables here. The same variable, but we have two of them. For this one, my recommendation is that you always move the smaller of the two variables, of the two numbers on the variables. So here we have negative 3 and negative 3u and negative 5u. Negative 5u is the smaller one, so I'm going to move it over. I'm going to add 5u to both sides. This cancels, leaving negative 20. Negative 2, negative 3u plus 5u is a positive 2u. From here, I'm going to move the constant. It's negative 2. We'll add that over to the other side. 2u equals negative 20 plus 2 is negative 18. And finally, I'm going to divide off the 2. This cancels. U equals negative 9. Number 14. This one looks tricky, but it's really not that bad. So this whole side of the equation, the x plus 5, is being divided by a 6. Here's the good news. You can easily get rid of that 6, so you no longer have a fraction. So again, we are dividing it by 6. So if I want to get rid of it, I just have to multiply it by 6. I drew these parentheses so that you could hopefully understand that we're multiplying all of this by 6 here. And then remember, what you do to one side, you do to the other. So I'm going to multiply this by 6 as well. So this cancels, leaving just x plus 5. 6 times negative 1 is negative 6. And now we have a very simple equation, which is nice. Move the constant, the 5. I'm going to subtract it over. And x is negative 11. It's not bad. 15. This is more like the types of problems you will see on the SAT because it requires a different way of thinking. If 7n plus 3 equals 4/3, what is the value of 7n plus 5? So instead of just asking us what n is, they want something else. They want another expression that has n in it. I'm going to first write out my equation. Now normally what I would do personally is I would go ahead, I'd solve for n, that way no matter what they give me, I can plug it back in. But actually that takes a lot of more work than what I'm about to show you. So again, they want me to have 7n plus 5. Well, I have 7n plus 3. So think for a moment, is there a way I could easily make this 3 into a 5? Yes, there is. All you have to do is add 2. Now, I can't just do that without also doing it to the other side. That's how we keep it balanced. This may feel weird because you're used to doing this when you solve equations, and I just did it in 3 problems. Looking at 14, for example, everything I did for each step was to cancel out something. I canceled out something every time. I did the same thing in 10 and 11. Notice in 15, nothing's going to cancel. This becomes 5, and then this will definitely not cancel as well. We're going to get a different number besides 0 out of that. So it feels weird doing this. It feels just kind of random. But you are able to pretty much do anything you want to an equation as long as you do it to both sides. So why am I doing this? They want to know what 7n plus 5 is. So essentially I'm solving for 7n plus 5. I've already got it on one side by itself. So once I figure out what this number is, I'm done. All we have to do is get our answer. 4/3 plus 2, and this is like 2 over 1. Right now I can't add these because they have different denominators, so let's fix that. I want them both to be a 3. So let's multiply the top and bottom of this fraction by 3. And I have 4/3 plus 2 times 3 is 6, 3 times 1 is 3. When you add fractions, you keep the bottom the same, so this will be a 3, and then you add across the top. 10/3. And that is my answer. One more problem. This tackles a little bit of a different concept, the inequalities. So when you solve inequalities, a lot of the steps, the rules are the same as when you solve an equation that has an equal sign. But there are a few other things you need to keep in mind. So instead of drawing a line down the middle of the sign, I'm going to kind of circle it, if you will. This was how I taught, genuinely, how I was taught. So still creating that left and right side idea. What I'm going to do from here is I'm going to solve like I have been, and then when I run into something that's a little different because it's an inequality, I'm going to point it out. One big thing to keep in mind with inequalities. I know a lot of you guys really prefer to keep the x or whatever variable it is on the left side of the equation because that's how you're used to seeing it, and that's perfectly fine. For inequalities, I'm going to tell you it's pretty much you have to have it on the left side for sure. There's a reason why we do this, and I'll explain that in a moment. So wherever I move x, it needs to be on the left. First things first, I've got these parentheses in here, and I haven't done one of these on this paper yet, so it's actually a good thing I chose this problem. But when you have parentheses with extra things inside of it, and then a number outside of it, you're going to distribute it. Remember, distribution is just multiplying. -4 times x is -4x. -4 times 3 is -12, is less than or equal to -2x. From here, we're going to keep solving like normal. Now, normally, if this had an equal sign, I would move the -4x since it's smaller than -2x. But since I want x to stay on the left side, I'm not going to move this one. I will move the -2x. So I'm going to add it to both sides. This cancels. That gives me -2x minus 12 is less than or equal to. Reminder, you can't just have nothing here. It is nothing. This does cancel out, so that nothing, that's 0. That's how we represent that with a number. From here, we're going to keep solving. Move the constant, -12. We're going to add it to both sides. Bring down the -2x is less than or equal to 12. And then finally, we are going to divide by -2 to get x. There's one major rule when you're solving an inequality, and it's this one. When you divide or multiply by a negative, you are going to flip the sign. So this is now going to become a greater than or equal to. And 12 divided by -2 is -6. So I'm going to add a little note in here. If you divide or multiply by a negative, flip the sign. Lastly, if you notice the directions, it says solve and graph the inequality. So when we graph this, we only have an x. So we're not going to go to the coordinate plane and graph a whole line. We have just a number line here. We're going to put the answer we got, -6. And then I'm going to put a number that is above it, a number that's larger than it. So if we go to the right, we'd have -5. If we went left, we would have -7. Just to get an idea. So I'm going to put a dot on the negative 6. Now, if you remember, this is going to be a closed dot, since it has that or equal to as an option. So I'm going to add a little note here. Closed dot, since it's equal to. From here, I'll explain this in a moment. I'm just writing it. With an inequality that's different from an equals, so like up in number 14, x equaled negative 11. That was the only number that x equaled. For 17, we have a lot of possible options, well, a lot of options for x. X is any number that is bigger than or equal to negative 6. So I could put negative 6 in here since it does equal itself. I could put negative 1 in here. I can even put 0 in here. I could put 1,000 in here. All of those answers would work to make this statement true. So that's why we have to have the line, because there are an infinite number of answers that could go into here. So here's the other thing I wanted to show you with inequalities. This is the reason why you have to have the x on the left-hand side. If it's on the right, this trick I'm about to show you does not work. Since it's on the left-hand side, the sign points in the direction of your arrow. So notice how it looks like it's pointing to the right this way. If I were to draw a little arrow here, it would be pointing to the right. That is how I'm going to draw the arrow on my line. So I know it's negative 6, and any number bigger would work here. So I'm just going to add one more note, points right. And that's all there is to it. So if you have any questions over the notes or over any of the other problems that I didn't cover, feel free to come see me in person. Otherwise, I hope you have a wonderful day. Bye!